Hi everyone. In this video, we're gonna be estimating the difference of two population proportions, as you see on my screen, p1 minus p2. So still we're dealing with confidence intervals. We saw so far estimating one population proportion, estimating one population mean, and estimating one population standard deviation. In this lecture, we're gonna see how we can estimate the difference of two population proportions. Now, the confidence interval is written the same way. If you want to estimate the difference of p1 minus p2, that's a number between p hat 1 minus p hat 2. These are the sample proportions, minus e, which is the margin of error, and p hat 1 minus p hat 2 plus e. Now let's get familiar with the formulas. First, then I'll show you how you can use your calculators. E is the margin of error, and that's z sub alpha over 2 times square root of p hat 1 q hat 1 over n1 plus p hat 2 q hat 2 over n2. So I put a little note for you here. Round the interval limits to 3 significant digits, and we will go over that. Now, E, as I said, is the margin of error. Z sub alpha over 2 is the Z critical value. And of course, we always use the standard normal distribution. P hat 1 is the sample 1 proportion, or the proportion of the sample 1. You write that as x1 over n1. P hat 2 is the sample 2 proportion, or the proportion of sample 2, and you write that as x2 over n2. There's some requirements here. First of all, p hat 1 and p hat 2 are from two random samples. The two samples are independent. Independent, that means you pick them from different, sometimes populations or completely different places. So, and I will go over independent and dependent sample. For each sample, if you do n times p hat, that should be greater than or equal to 5. And if you do n times q hat, that should be greater than or equal to 5. So you can go ahead and use that confidence interval. And remember, as I said, q is always 1 minus p. So q hat is always 1 minus p hat. This is an important note, especially sometimes when you use your calculator. If p hat 1 and p hat 2 are given, to calculate x1 and x2, we use these formulas. So, however, we isolate x1. If p hat 1 is x1 over n1, then x1 is n1 times p hat 1. And if p hat 2 is x1 over x2 over n2, then x2 will be n2 times p hat 2. To directly use your calculators, step number 1, can you go to stat? Then step number 2, you highlight test. That's the third item on the screen. So to the right. Then you scroll down until you see to prop Z interval. So, and you can use that one. So to prop Z interval. And then you have to just input the givens, and it's pretty straightforward, very fast with the calculator. I do have an example for you here. So the example says construct the indicated confidence interval for the difference between two populations, P1 minus P2. Assume that the samples are independent, one of the requirements is there, and they have been randomly selected. So you can try to see n1 times, you can find p hat 1, and then 1 times p hat 1 should be greater than 4, and it will. And same as n2 times p hat 2. So, and they are, because it just x, which is 65 and 116. And if you do 1 q hat 1 times n1 and q hat 1 times n2, you will find that to be greater than 5. And usually in these problems, it's assumed that they are. 98%, construct 98% confidence interval for the difference of the two proportions. So I wrote the interval first, as we saw, p hat 1 minus p hat 2 minus c, p hat 1 plus p minus p hat 2 plus c. P hat 1 is x1 over n1, x1 over n1. 65 over 90 is 0.722. P hat 2 is x2 over n2, given in the problem. 79 over 116, so it's 0.681. And to find the critical z-value for 98% confidence level, as we said before, 98%, that means this middle area is 0.98. To read that value, you have to find the area in the tail, which is 1 minus 0.98 divided by 2, and you get 0.01, and you just do inverse norm 0.0101. Always 0.1, because we do use the standard normal distribution for critical z values. You get negative 2.33. However, for calculations, we always use positive 2.33. So the margin of error is going to be 2.33 times square root of, just substitute the values we found, 0.722 times 1 minus 0.722 divided by 90, which is n1, 0.681, which is p hat 2 times 1 minus 0.681, which is q hat 2 over 116. And if you use your calculator, you get 0.149. The interval, we have everything now. P hat 1 minus p hat 2 is 0.722 minus 0.681 minus 0.149. And p hat 1 minus p hat 2 is 0.722, again, minus 0.681 plus this time 0.149. So you get negative 0.108 and 0.190. Let's check the answer. It's right here. So the answer is D. D is the answer. So with calculator, as I said, go to stat, highlight tests, scroll down to B, and you're going to see two prop z interval. The calculator is going to ask you for x1, n1, x2, n2, confidence level, don't forget is 0.98, and then just enter, calculate, and that's what you're going to get. 0.1078, 0.19018. So same answer. If you round it to 3 decimal significant figures, then that's what you get. There is another example here, number 2. In a random sample of 300 women, 50% favored stricter gun control legislation. In a random sample of 200 men, 26% favored stricter gun control legislation. Construct 98% confidence interval for the difference between the population proportions, P1 minus P2. Now, in this case, we notice x1 and x2 are not given. So we can go ahead and calculate them. x1 is n1 times p hat 1, 300 times 0.5. These were given. So you get 150. And x2 is n2 times p hat 2 is 200 times 0.6, and you get 52. For hand calculations, we don't need x1 and n1. because we only use p hat 1 and p hat 2. But for calculator, we do need them. So make sure to know how to get those values. Same formula. Z sub alpha over 2 is square root of times square root of p hat 1 q hat 1 over n1 plus p hat 2 q hat 2 over n2. 98% we just saw is 2.33, and it's 0.5 times 1 minus 0.5 divided by 300, and 0.26 times 1 minus 0.26 divided by 200. And if you do that, you get 0.099. We can substitute now. The interval is 0.5 p hat 1 minus p hat 2, which is 0.26 minus 0.099. The margin of error 0.5 minus 0.26 plus 0.099. You get 0.141, 0.339. If you do the same thing with calculator one more time, you go to stat, highlight test, scroll down to B, which is to prop Z interval or Z int. You need x1 and x2 here. That's why we calculated them. So 150, 300, x2 is 52, n2 is 200, confidence level 0.98. And if you do that, the calculator will directly give you the interval. So again, this was estimating the difference of population, two population proportions. So next, I'm gonna go over estimating two population means, and that's gonna be on the next lecture. Hope everybody is doing well. Take care of yourself, and I'll see you next time. Bye-bye.